I've talked, so I'm going to reset this. I'm going to start by asking that somebody, some kind person, that would be you, sir, would hand these cards out, one to each person, because I'm going to give you, this is a live demonstration. First of all, welcome to the NASA booth. My name is Kevin Hussey, and I am a manager of the Visualization Technology Applications and Development Group at JPL. We're one of several groups that do visualization technology. Ours just happens to have it in the name. There are 13 of us, and our job is to take all the scientific and engineering data that comes back from our missions and use any technology, well, any legal technology that we can get our hands on to portray these in a way that's more understandable to the public. So I'm going to show you how you can do this. Every single thing I'm going to show you, you can do at home on a Mac or a PC. We do have a series of applications that work on iOS and Android. I'm going to stick to the eyes products that are Mac or PC. I'm going to start by taking you to that website that card you have. That card is the key because it takes you to eyes.nasa.gov. The most important button, of course, is this big blue one to download the app and install it. Now I'm going to assume that all of you can do that. It's not that hard. In fact, it's what you're going to download and install is a very small, about a 75 megabyte video game. And when you're successful, you're going to get that icon, NASA Eyes icon on your desktop. When I start this, you're going to be given what I call the 4 different levels. I think of it as a video game because we build it in the Unity 3D engine. We are rewriting it now to work in WebGL. That'll take us about a year. So we're going to be using this one for a while, so you still have to install. Now, so we have eyes on the Earth, all right? Eyes on the solar system, and there's 2 versions, a simple and advanced version. After seeing my demo, you're not going to need the simple version, but it's interesting, it's different. And then eyes on exoplanets, which I used to warm up with this morning. These four buttons down here are just bookmarks into eyes on the solar system. We highlight interesting things that are happening, and I'm going to show you the vanilla eyes and take it from there. I will visualize the speed of light for you, okay? But I'm just walking you through this, so my goal is to have you try this at home. So I'm going to hit advanced. Again, this is a live demonstration. We're starting eyes, and when we do, I'm going to go full screen. There's a button over here. We ask you to go full screen. It just looks a lot nicer. And you get what looks like a very simple diagram of the solar system with a couple of huge differences. We've just changed the mouse into a virtual camera that you can put anywhere in the solar system from 1950 to 2050. I'm just going to scroll in with the scroll wheel now, and you can see I can move in. Then I'll just click and drag on the desktop, and I can move the camera anywhere, inside or outside the solar system from 1950 to 2050. The secret is that anything with a label is fair game, okay? So for example, I'm going to just double click on Jupiter. And if I do double click on Jupiter, you'll see that it will fly me out to Jupiter, will download the data for Jupiter, and now your camera is orbiting Jupiter, right? Now if I look off in the distance, when I first get there, I can see at the bottom left I'm given a panel. When we do have some additional information, we were given a model, a mathematical model of the radiation field, so we added it in here. So you can see that Jupiter, those are a rendition of the radiation field. We also were given a model of the magnetosphere, and then but the auroras. All right? So here are the various things that we have for Jupiter. But what's interesting is, if I go out here to Juno, I can see that we have a spacecraft named Juno, and again, because it has a label, I double click on it, I'm now orbiting, my camera's now orbiting Juno. And if I look back, or I look toward Jupiter, I can see that there's Jupiter, there are the moons. But what's cool about this is what you'd see if you were at Juno now, minus the lines, okay? There are no lines in space, regardless of how we depict them. Down here, there's a little camera icon. If you hit this little icon, it makes it a more realistic view. All right? Now I'm going to go ahead and put my lines back on. It's hard to navigate. But I can change time. I can change time many different ways. I'm going to show you two. We have a little time slider here. I can move time forward because on the, whoops, went a little far. I'm going to say now again. Here's the now button. Okay, we're back to December 14th at 9:50 in the morning. Okay. So if I just type in here, December 16th at 9:50 in the morning, let's see where Juno will be on the 16th. It'll be getting ready to do another science pass of the planet. Okay, so this is just a little introduction. Some of the features that people don't know about is we have, besides being able to put yourself anywhere between 1950 and 2050, place the camera anywhere inside or outside the solar system, we have special tours and features. And I'm going to introduce you to this now because I want you to be aware of this. So I'm going to start with, this is the vanilla. What you're seeing is the vanilla interface for eyes. Now I'm going to show you a feature that we did just for the Juno mission. And when we have a feature, what we have is the user interface becomes just about that one mission. It's no longer eyes on the solar system, it's more like eyes on Juno. And again, we start you off, if you notice, we keep things very accurate. Here's the date, this is right now, and that's the view, okay? I'm gonna say explore, and we're gonna have the entire interface now is about this mission. So this is the home. This is a button that will allow you to explore the Juno mission. You could say I want to look at the different phases or events. So let's go to Juno events. And of course the orbit insertion was very interesting. So if we click on orbit insertion, we will set this up so you can see what happened while we were inserting on July 4th, 2016. Here we happen to have a picture-in-picture, okay? I can turn on again the Jupiter's rings, the aurora, the radiation belts, and if I want, I can double click on Juno and have both looking at it from this perspective. As it flies in, I can close this window. So you get the idea that the modules are designed specifically for a mission. There's a little thing here on the spacecraft where you can look at the different spacecraft instruments. Okay, so this is eyes, this is some of the modules. Now, the reason I showed you this is I want to go back, I'm going to go back to vanilla eyes, if you will, and say that, all right, to demonstrate how we visualize the speed of light, I'm going to go to the Cassini module and set this up. So as you know, Cassini was launched October 15th, 1997. It almost made 20 years. We literally flew it into the atmosphere of Saturn on the 15th of September of this year. And this is the module that we did for Cassini. And I'm going to go ahead and enter this module now and just show you that there are different buttons. There's the Cassini mission button, where you have mission phases and trajectories. There's a whole sequence of just things about Saturn's rings, all sorts of things about the rings. We have a whole segment of moons, where you can literally, if I say moon flybys, you can ride along with Cassini when it does every one of the flybys that it made. All 23, all 127 of the Enceladus flybys. I'll say, Titan flybys. I'll just pick, let's do a plume flyby. Here's one in 2015. So if you click on this, now none of this is a video. This is all running in the game engine. It's just scripted. So we'll set the timeline at the bottom. We'll move time up to the proper Enceladus flyby. And then it will take you and let you watch this. Now I'm showing you this one because see those plumes coming out of the bottom? Those plumes are the reason that we needed to go ahead and ditch the spacecraft into the atmosphere purposely. We were told by NASA's Planetary Protection Division that if the spacecraft was running out of fuel and we didn't want to have it crash into Enceladus that has a liquid water ocean and pollute the place. So instead we flew it into Saturn on the 15th of September of this year. Now, as a part of that, we were asked to come up with some visualizations depicting the grand finale. So we have a whole grand finale sequence here where you can watch, for example, I'm going to show you the proximal orbits. Here are the last 22 orbits. and they were all inside the ring plane. These are the last orbits of Cassini, right? You can go back and watch. You can literally watch this entire mission in real time, starting at 1997. Now, it would take you 19 years, so I don't recommend that, but you can watch any portion of it. And by the way, every motion that the spacecraft makes is in here. Every single turn is accurately depicted. So now, I'm going to go back here to grand finale, and I'm going to set this up. So I'm going to set it by saying, when I click this final transmission button, what you're going to see is you're going to see the Cassini spacecraft, and then you'll see a TS followed by a sine wave and a line that will be showing you the start. TS stands for transmission start. It'll head from Cassini, and it's going to, in real time, travel all the way to the Earth. Okay? So we actually, again, we did this for the mission. Now, I want to set this up, and I like to say that people don't realize just how slow the speed of light is, okay? And I say that, people smile, they think, okay, this guy's a little crazy, it's really fast. Actually, it's fairly slow. So here's a demonstration. I want you to watch the beam of light. Watch how it starts and travels from my flashlight to the NASA logo, all right? Now watch it. Watch how it gets there. Ready? It's on. Do you see that? Do you watch it travel from here to there? Seems pretty slow, right? Actually, it seems pretty darn fast. But I want you to watch that same speed being depicted here in NASA's eyes. So you're going to see the TS travel at the speed of light back toward the Earth. So I'm going to hit final transmission. There's Cassini, and there goes. Now that's traveling at the speed of light. I'm going to tip this down and have it, I'm going to scroll back, and it hasn't yet left the Saturn system. So there's Iapetus, one of the distant moons, okay? So it's traveling at the speed of light, which is 671 million miles an hour. Now I'm going to give us a little bit more of a head start. I'm going to speed up the rate to about 5 minutes a second. So I'm going to be going like hundreds of times the speed of light. And every 5 minutes, I put a little marker. And you'll see these little markers come flying out. There went one. I'll go another one. I'm going to now back to real rate. So now I'm going to tip down again and scroll back. And these markers that you're seeing, there's 105. That means there's 195 minutes left in the mission. This is a 200-minute marker. So each of those every one of those is traveling at the speed of light. Now I'm going to scroll back until you can see the orbit line of Jupiter. So there's Jupiter's orbit line. Now keep in mind that all of these text characters are traveling at the speed of light. And at the scale of the solar system, it's pretty slow. When you think about it, we had to wait 85 minutes to receive any signals from Cassini when it was at Saturn, back at the Earth. So yeah, the speed of light in terms of our context here on Earth is pretty darn quick. But as soon as you get outside, when you're out in the solar system, it slows down, so to speak. And then when you start talking about intergalactic travel, we need something a little quicker to get places. All right, so I'm going to go ahead and drive this forward because I want to show you that, in fact, you know what? I only have 2 minutes, so I'll speed this up really quick. I want to leave a minute for questions. So let's go ahead and let it connect with the Earth. In fact, I'll let so I can see TE. You'll see transmission end. Okay, then let's look at it from Earth. Anything with the labels, fair game. Oh, come on. And you'll see that it's going to go right into Canberra, Australia, which is where we have our tracking station. I'll turn the light on so you can see it. It was nighttime. There's where the signal's being reached, and then looking back, here it comes. And you can watch them come in at the speed of light, but as soon as you can recognize them, they hit the Earth. All right, so I've introduced NASA's eyes. There's eyes on the Earth, solar system, and exoplanets. Here's solar system. If you want to know how to get it, it's free. Actually, it's no additional cost to U.S. taxpayers. Thank you very much for paying your taxes. You can pick up a card that tells you how to get there. And I have literally 35 seconds to answer your questions. Any questions you have regarding either what you've seen or about NASA's eyes? No questions? Yes, sir. Go ahead. Just shout it out.
When you go to like mission flybys and stuff like that, are there also pictures available taken?
Okay. The question was, when there are mission flybys, are there pictures taken as well? The question is yes. There's a whole gallery of images that are linked. You can come here and you can look at pictures galore. Okay? I must stop now because the next speaker needs to start. Thank you very much.